A confirmation about the audio, please, guys. If the audio is clear and available, thank you. So now we come over to the last session for the day. And here, now we will continue forward with the aspect of plate tectonics, and then we will enter into the portion about environment, about the portion of earthquakes and volcanoes also. Okay. Now I understand that weekend sessions can be particularly tiring and long, and especially when you consider a subject which, such as geography, which is technical. If I would have been talking about the prime ministers and the presidents of the country, I understand that it would have evoked a certain sense of interest. But then it is here when we talk about geography. See, if you have to find interest in this subject, that will only come if you are able to relate it to your surroundings. That the Himalayan region, for example, that is something that you have known from your childhood days, that yes, there is a certain mountain range, that is the Himalayas, which is very high. But then when you then think about it, that this was a land which for a significant portion of time in history was underwater, that is what will pique your interest, that is what will intrigue you significantly. Now, when we talk about the region of Himalayas, remember, we have also had a conversation that how do we know that the region of the Himalayas at one point of time were underwater? How do we know that? How do we get at that particular conclusion? So basically, the geologists, while they were carrying out the researches about the type of rocks that you find in the mountains, they came across the fossils of the marine organisms. Fossils and remains of marine organisms that high up in the mountains, that simply did not make sense. And also the type of rocks, for example limestone, etc., has been found in the region of Himalayas. Now limestone typically is to be found in those areas which have been in underwater at some point of time in the history. So that all those particular evidences, they further cemented the fact that yes, indeed, that region that we count as the Himalayan ranges as of now, the highest mountain peaks across the world, that region was a flat ocean floor few million years back. So that tells you that the land around us, right, the absolute land features around us, they are prone to changes, and they undergo many different kinds of changes over a span of few hundreds, thousands, and millions of years. Okay. So now we proceed further with the other types of plate movements, other types of plate boundaries which are referred to. Now, here, when we were talking about the convergent plate boundaries, by the way, so convergence of plates, always, whenever you have the convergence of plates, you will observe that some of the plate boundary or some of the material of the plate that undergoes subduction and that is consumed. So that is why these plate boundaries, they are also referred to as destructive plate boundaries or destructive plate margins. Okay. So convergent plate boundaries, they are referred to as destructive plate boundaries or destructive plate margins because a substantial and a sufficient portion of that plate undergoes subduction and is consumed in the process, and basically ends up getting in the way, in the sense that it goes underground, it goes underneath the other portion of the plate. So that is the case of the destructive or the convergent plate boundaries. Now, Indian plate and its movement, so Tethyan seafloor got uplifted. It is an ongoing motion, and the Himalayas height is still rising. It will continue to rise as long as the Indian plate continues its forward push. The Himalayan height will continue to increase. And because of the various different types of cracks, fault lines, etc., which have been created in the process, this is a zone which is very prone to earthquakes and also ends up leading to various instability of the plate. So that is why the northern portion of the country, that is the region which is very, very prone to earthquakes and events of seismicity. Now, after this, we come to the portion of divergent plates. Divergent plate boundaries means the plates are moving away from each other. Now, when the plates move away from each other, after some time, you will have the creation of a newer crust, right? Because it is a convective current which leads to the divergence of plates. So, after some time, that convective current in itself will give rise to the newer crust formation as well. So that is where the divergent plate boundaries, because it involves the creation of a newer crust, it is also what we refer to as the constructive plate margins. Constructive plate boundaries. Because it leads to creation of newer crust. Of newer crust. Now, the divergence, as we have studied already, is purely led because of the existence of a convection current in the region of the mantle, and that is how basically they are pushed away from each other. Now, if it happens under the water, now there you will have the creation of mid-oceanic ridges. Okay, underwater, in the case of underneath the oceans, when this divergence takes place, you have the creation of these mid-oceanic ridges. And when it happens over the case of the land, now there the divergence, what it does. So this is the scenario that you observe in the region of Eastern Africa. Now observe these large ditches which get created, these large trench-like formations which come into existence, which get created. Now these are what we refer to as rift valleys. Okay, so rift valleys, basically they will come into existence when you have a tensional pull, when you have a significant amount of tensional pull which gets created. So that ends up creating these rift valley like structures. Okay, now these rift valleys eventually they will get much wider, and you will have the nearby oceanic water also entering into these areas, and this will form a shallow sea, a small water body. Here just imagine the size of this rift valley, all these small structures that you see, that you are able to spot out, right? All these structures that you see, they are basically large two-story, three-story buildings out there. So you can imagine the size of this rift valley. So these rift valleys, they are again created as the land, because of the tensional force, as it pulls apart, the central portion simply sinks. We will study much more about the rift valley and its formation. It is referred to as graben fault. We'll study it in the next module. So this is observed when you have the divergence happening underneath the land areas. Due to divergence underneath land areas. Okay, so example, East African Rift Valley. I'll show you the East African Rift Valley also, where it is. East African Rift Valley. Now, in these cases of rift valley structures that we come across, that we talk about, now these cases of rift valley structures, here you have to understand that basically not only rift valley, but also when you, let's say, we talk about in general the divergence of plates and the eruption of newer materials, eruption and expulsion of magma molten materials. Now there, the sometimes the volcanic eruption can happen in point areas, but it is in these divergence of plates where sometimes you will observe that a large crack has opened up on the ground surface, a very large crack, which can span for many kilometers, and molten materials, they start coming out of it. What we refer to as a kind of a fissure volcanic eruption. So that is something which is very common in this. So generally divergence happens across the region of the mid-oceanic ridges. So that is where the divergence happens. As of now, the fastest rate of divergence is experienced in this area, where you have the Pacific plate on this side, and here you have the Nazca plate. This is what is referred to as the East Pacific rise or the Chilean rise. Here, the rate of divergence as of now is close to around 15 to 20 centimeter per year. But it is not going to continue forever. So it will continue for a few million years, then maybe the rate of movement, etc., that comes to a standstill. So that is how the rate of divergence in various parts that ends up varying across the entirety of the mid-Atlantic ridge also. The mid-Atlantic ridge, here also there is an active divergence which has been happening for almost past 200 million years since the Atlantic Ocean came into existence. And this has led to creation of certain volcanic islands also. For example, take the case of Iceland. The region of Iceland, it lies bang on the middle of the mid-Atlantic ridge. That is why Iceland experiences frequent volcanic eruptions. And also it is in the region of Iceland where you will be able to observe the kind of volcanic eruption that we were talking about, where a large crack opens up, simply opens up, and you have lot of materials which are exited, right? So what we refer to as the fissure volcano system. So this is the fissure volcano. Observe a large crack which has opened up rather than a conical volcano that we are generally used to watching. So a large crack has opened up, and observe that how the molten materials, they start coming out. Right. So fissure volcanoes, we will study about it again furthermore in the next module. So these are when magma or molten materials emerge out of large cracks on the surface in a linear manner. Okay. So that is how you have the creation of these fissure type of volcanoes. You have very famous fissure volcano that you observe in the region of Iceland. And the last time that major eruption happened was in the 1770s and the 1780s, where you had a large Laki eruption. Laki eruption in Iceland is an example of that. Laki eruption in Iceland. Okay. So that Laki eruption, which did occur in Iceland, here it is said that basically a large crack worth close to around 37 kilometers that opened up. And it is expected that thousands of kilometer cube of molten materials, they basically exited that crack and they started spreading over that entirety of the area. So all this happens because of divergence. Here you will observe that in the case of Iceland also frequent eruptions happen. You have the North American plate on one side, you have the Eurasian plate on the other side, and that is where here you have the mid-Atlantic ridge which passes through here. So that is why Iceland also basically has been created due to the spread of the magmatic material and their deposits thereby. So sometimes you have these particular divergent boundaries also will lead to the creation of certain islands in certain cases. Okay, so divergent plate boundaries, they are always associated with divergent boundaries. They are basically associated with volcanic eruptions, also minor earthquakes. So these minor earthquakes that we talk about, so why do they happen? If the plates already are moving apart, why will the earthquakes happen? Because as the plates tend to move apart, the molten material tries to rise up. But oftentimes that passage of movement of the molten materials is not very smooth. So while exiting those vents, the molten materials oftentimes end up shaking the surface. So that is when the earthquakes are experienced across the divergent plates. Okay, so these earthquakes mostly are experienced as the molten materials they try to come closer to the surface. Mostly are experienced as molten materials try to emerge to the surface. Okay, it can lead to the creation of mid-oceanic ridges. The divergent plate boundaries can also lead to the creation of the rift valley structures, and also sometimes, as we observed in the case of the island, in the case of Iceland, island formation can also happen when you have excessive volcanicity. Then island creation can also take place. Now we come to the transform plate boundaries. Before that, a couple of questions. Mukul, why didn't divergence occurred in case of Himalayan plates, as there might also be convection current underneath? See, if there would have been convection current underneath it, then divergence would have happened. It is not a matter of guessing it that that could have been present, but then some external force, because of some almighty being, that is why Himalayas are getting created. That is not the case. Whenever, if at all, there will be creation of a convection current, let's say even tomorrow, if there is a convection current which comes up underneath the region of the Himalayas, there will be divergence which is happening. There is no second ways about it or no two ways to think about it. It is a very simple logic thereby. And Priya, does the molten material stays for some time or continuous form? Does it run for some time, stops, and again molten state? Or does the molten material stays for some time or continuous form? Does it run for some time, stops, and again molten materials? So are you talking about the volcanic eruption in the case of the Fisher volcano, Priya? Or so when you are talking about the process of these kind of volcanic eruptions, so the molten materials, when they fill up the entirety of the magma chamber, only then they start coming up. And when they are in substantial quantity, that is when they start coming up to the surface, and that is when they will start flooding the surface. And why only why only landmass form in islands? Why not entire Atlantic? Again, I'm unable to understand this question. When we say that why only landmass, what is an island? Island is basically, when you talk about an island, island is a landmass surrounded by water bodies from all sides, isn't it? But having said that, if your question is, for example, if your question, Ganesh, is that why is it that only Iceland has been created? Why not the entire amount of or the entire region of Atlantic? Why the land has not been created? Because that much magma did not erupt. You had a situation, as I told you, around 95 million years back, where you had significant amount of volcanicity. So a lot of various different island chains in the region of the Caribbean islands, they got created. Many of the underwater mountains got created. But then to think about it, that such amount of materials, that the entire Atlantic Ocean would be covered by it, that much amount of magmatic eruption does not happen. Okay. Fissure volcano can happen anywhere on the earth, or is there a specific region? Generally across the portions of divergence where there's a large crack which opens up, only in those areas. What happened in Morocco earthquake? Which kind of plate movement in Morocco earthquake? Again, a convergence of plate. You had the Anatolian, the African plate, they and the Eurasian plate, they were at play. And Libyan region and the region of Morocco, they basically are frequented with earthquakes. And even if you take a look at the historical records, these are the regions which have been frequented by earthquakes significantly larger number of times, because the African plate is also moving further northwards. The western part of Africa is moving northwards. It is in a way colliding with European region. That is why that is the region where you have earthquakes, and in the region of Mediterranean you have volcanic eruption as well. So in that area the plate activity is significant. That is why you also had the very disastrous Turkey earthquake, which also happened in the recent past, because in that region the plate movement is active. Okay, so you had the African and you had basically the Eurasian plate which were in uh, activity there. Now, the transform plate boundaries. Now, these are basically the plate movements where the plates neither they move towards each other, nor do they move away from each other, but they move parallel to each other. That is why these neither will destruct a particular region, nor will they create a particular new crust. These are also what are referred to constructive plate boundaries. Constructive plate boundaries. Okay, that is why these are known as the constructive plate boundary, because in the sense, or not constructive, rather conservative. They neither lead to the creation of a newer crust nor the destruction of the existing crust, hence the conservative plate boundaries. Generally, transform plate boundaries are found perpendicular to the divergent plate boundaries. Let me write it down, then I will explain this phenomena as well. Generally, not always though, sometimes, generally found perpendicular to divergent plates boundary. Why is that the case? And what do we mean divergent plates and perpendicular to it? So let's suppose you have two larger plates which are undergoing some or the other form of divergence. Let's assume. Okay. Now let's assume these plates are moving away from each other. So this will be your divergent plate boundary. This is what will be regarded as a divergent boundary. Now here, as we have discussed the case earlier also, now as they are moving away, the rate of movement in different parts might not be same. Let's suppose here the rate of movement is 2 centimeter per year. Here the rate of movement, let's suppose, is 15 centimeter per year. It can happen because these are the regions across the planet. If you think about a sphere, you might have different rates of convection current happening in different areas. So due to that, there will be a crack which might develop here. And this will form a transform plate boundary. Plate boundary. Now this transform plate boundary has been created because there is a differential rate of divergence amongst the plates. The portion to the north is moving at a different rate. The portion to the south is diverging at the different rate. That is why you can have the creation, you can experience the creation of a transform plate boundary in the process also. Now that is what basically is observed, that in majority of the cases the transform plate boundaries, they are perpendicular to the divergent plate boundaries. Here if you observe this particular image, observe here, you have a transform plate boundary in this region, because the rate of divergence that you observe here and the rate of divergence that you observe here, they are different. Even though the motion and the direction of the motion is the same, but the rate of movement is slightly different. In fact, when we talk about the region of Africa, here it is something which has got a much more complex movement like this. So that is why this is going to have a kind of a transform boundary which is perpendicular to the divergent plate boundary. Now, when you have the plates which are basically moving parallel to each other, now immediately because of that parallel motion, they will cause resistance. They won't be able to move parallel very easily. So due to that resistance, oftentimes very large cracks they open up on the surface. Very, very large cracks they end up opening on the surface. Right. What we also refer to as the transform faults. And any movement which happens across these cracks. Now, why will the cracks develop? Because as the plates are trying to move parallel to each other, due to the resistance that they offer, and because the other plate is trying to overcome that resistance, so because of that force inequality, there is development of these crack like features. And when you have the development of these crack like features, these become zones of earthquakes, very high magnitude earthquakes. They strike the region, for example. And these are basically, you have large cracks, these are referred to as the transform faults. Okay, so very large cracks they open up, and they will lead to the creation of these transform faults, and any kind of movement happening across these cracks will instigate very high magnitude earthquakes in the process, lead to very high magnitude earthquakes. For example, take the case of California. California is present in which part of North America, eastern or western? Let me see. Are we aware where California is situated? Western, good. So California is situated in the western part. Now there you have a transform plate movement which leads to the creation of a large massive fault that we refer to as a San Andreas fault. And that San Andreas fault basically is a zone where frequent earthquakes they do happen and they do strike that area. So that is why when we talk about these transform plate boundaries, the plates move parallel to each other, neither creating nor destroying a feature, leads to significant tension being built up in creation of earthquakes and faults. Example, San Andreas fault. Hollywood has made up multiple movies and games are around this very name of San Andreas fault. So you would be aware about many of them. So that is the San Andreas fault. So this is a kind of a transform fault, okay, created across the transform margin. So zone of high magnitude earthquakes. Okay. Priya, does the transform plate can travel in some direction like 2 centimeter? So see, it won't be that massive a difference between 2 centimeter per year or 15 centimeter per year, but surely the difference can be 2 centimeter and 5 or 6 centimeter per year. That much difference can happen, and that is enough to create a kind of a transform fault in the process. Okay. Now, then overall, if you observe this, so this is the major plates. Now here, take a look at the larger picture for a brief moment, and let us talk about what will happen in the future. So here basically, while the convergence etc keeps on happening, now it is the North American region and the South American region which continues to move westward, right? So the Atlantic Ocean in the near future is going to increase in size. There will be a substantial increase in the size of Atlantic Ocean. Pacific Ocean, the Pacific plate is undergoing subduction, but simultaneously across this region of East Pacific rise or the Chilean rise, you have divergence. So the Nazca plate, its size is increasing. So going ahead into the future, you can expect that the Pacific Ocean might start getting closed off from the northern side. Then African plate, here you have the development of the East African Rift Valley. The similar process was followed even in this region, where you have the Nubian fault and so on. So even this area, the Arabian plate that you see, that at for some substantial amount of time was very much a part of Africa. It was the creation of the convection current which has started pushing it away, and the creation of the Red Sea, etc., which has happened was because the Rift Valley which got created became deeper and deeper, and water from the nearby ocean entered into that area. So that is how you have the creation of these regions. Okay. Now going ahead into the future, this portion of Africa, that is expected to move further northwards. This region, eastern portion of Africa, is expected to move eastwards. Now here, the northern portion, as it will move northwards, it will be pushing into the Mediterranean Sea, right? And pushing into the region of Eurasia. So this is the reason why in the area of Mediterranean Sea, that is in the coastline of Italy, etc., you'll find many of the active volcanoes to be present. You have Vesuvius, you have Etna, Stromboli, all of these. Now, these volcanic eruptions, they are frequently happening because there is an oceanic crust, that is the Mediterranean crust, that is getting subducted underneath the Eurasian plate. And why is the Mediterranean crust getting subducted? Because the African plate is pushing it. So going ahead into the future, that is around 20 to 30 million years into the future, you can expect that just like the Tethys Sea floor closed and the Tethys Sea closed in the case of Indian plate, here also you can expect that the Mediterranean Sea might get closed as the African plate collides with the region of Eurasia, and you might have a fold mountain in place of the Mediterranean Sea. That might be the tallest mountain at that point of time when once it is created. The Indo-Australian plate, basically, the Indo-Australian plate is also getting divided. It is here that the division is happening. It is breaking. The breaking or the breakage has not been complete, but nonetheless, the breakage has been initiated. And all the plates which were once a part of the Gondwana land, they are basically moving northwards. So that is why the southern ocean around Antarctica, its size is also going to increase. So Atlantic Ocean, Southern Ocean, all their size is going to increase going ahead into the future. Now here you observe, now the region of the Himalayas, that is at a plate boundary, and hence it is going to experience active seismicity, active earthquake occurrence. Observe another region, the region around Gujarat. And listen to this carefully. Because other than Himalayas, Gujarat also experiences very heavy amount of earthquakes and high magnitude earthquakes. So why is it so? Because Gujarat uniquely lies at the plate boundary where three plates meet. You have the Eurasian plate, the Arabian plate, and the Indian plate. All these three plate boundaries, they have a junction at the region around Gujarat. So any movement which will happen either in Arabian plate or Eurasian plate or Indian plate, it will have an impact of the shaking of the ground surface in Gujarat. That is why historically Gujarat has experienced massive earthquakes, even as recent as 2001, where you had on 26th of January the massive Bhuj earthquake in Gujarat, which claimed many lives. So that is something which is a common phenomena in Gujarat. Historically, also, many of these earthquakes have happened in Gujarat, which were so massive that many of the areas under the sea, they suddenly, because of the adjustment of the rocks, many of the areas which earlier lied under sea were pushed up, and you had formation of small islands. Similarly, many areas were pushed down or they simply subsided because of the adjustment of the rocks. So that is a region frequented by earthquakes. Here I also want you to observe this particular arc, this arc that you see. This is what is also referred to as the Indonesian arc. Now, that Indonesian arc has been created partially because of the oceanic crust of the Indian plate undergoing convergence in the nearby oceanic areas. It is across this arc that you have the Andaman Nicobar Island groups. This is the reason why the only active volcano in India is present to the northern portion of Andaman Nicobar Islands in the form of barren islands. So that is basically the plate tectonics giving you an idea about not only what has happened in the planet, but going ahead into the future, what is it that we are expected or expected to experience. Okay. My question is, does the plate itself travel in other direction, like A part in northern and B in which particular? So this one you are asking. So here, Priya, your question is, if I name this as A, if I name this as B, B dash, I hope you are able to understand that we are taking a top view of this, right? We are taking a kind of a top view. So yes, this kind of a plate movement can always happen, that A simply moves away and B dash moves away. Is that the doubt, or is the doubt something else? Something that I'm unable to understand. Please specify. Any doubts that any of you have? In this case, B and B dash. So B and B dash both are moving in the same direction. Both are moving in a way eastwards, right? Both of them are moving in the eastward direction. A is moving in westward direction. So B is moving at a rate of 2 centimeter per year. Let's assume B dash is moving at 4, 5, 6 centimeter per year. It is not as if B is above B dash. It is, we are taking a top view of it. So if I have to explain it in this image, think about this as B, think about this as B dash. Both of them are moving at the different rate, and hence you have a transform boundary in between. Is that understood now? Or is there a doubt which prevails? Or is the doubt something else? Or any kind of doubts that anyone else has? Please let me know. But yes, such kind of transform plates can always come into existence. Okay. Now, we further expand your horizon a bit and we talk about the existence of, or the actual events that what happen across the planet. We have seen that yes, you had Pangea got broken into Laurasia or Angara land and Gondwana land, that broke up into the various different continents, and the continents are moving with respect to each other. But then, is that a one-off process across the planet Earth? The answer is no. Planet Earth has experienced multiple such events in the past, and where it has been the case that supercontinents they get created, and then they get divided into small piece of lands, the small subcontinents, the continents, they again come together, form another supercontinent, again they break together, break away from each other, again due to movement eventually all of them will club together, again they will divide. So there is a kind of a cycle where you have the creation of a supercontinent and subdivision thereafter. It is basically estimated that Pangea has been the third supercontinent. So before that also, you had two such events. Rodinia being the first one, where you had the creation of a large supercontinent, and then eventually it broke into multiple pieces. Multiple pieces came together, formed another supercontinent, again broke into multiple pieces, again they came together, formed Pangea. Pangea again broke into smaller parts, and then again going ahead into the future, that all those lands can come together to form another supercontinent. So this is a kind of a natural cycle of planet Earth. So this is what we also refer to as the Wilson cycle, given by Tuzo Wilson. Wilson cycle, where you observe land coming together to form a supercontinent, like Pangea, and again moving away to form smaller continents. Convection currents would again lead to the continents coming together and again drifting away. This cycle repeats itself every few hundred million years. So you will observe this cycle to be repeating itself again and again. So that is what we refer to as the Wilson cycle. So that tells you that Pangaea was neither the first supercontinent nor is it the last supercontinent. So going ahead a few 100 million years, maybe 100 million years from now, or a couple of 100 million years from now, all the land masses can again come together and they can again form a larger supercontinent. Okay. So why mountains are there other than the boundary of plates? Where mountains are there? Sidhu, which portion are you saying that mountains are there other than boundary of plates? So could you please specify? See, many of the doubts, you guys are not clear enough in the sense that I'm unable to make sense of it. Ural is okay. Why mountains are there other than the boundary of plates? Okay, that is your question. Okay, in forests like the Nallamala forests. Okay, so you're talking about the existence of mountains other than the plate boundaries. So basically, mountain formation can happen because of various different reasons. You have block mountains which get created, but also understand that, for example, if you take the case of the Aravalis, at one point of time, they were also at the plate margins, right? For example, if you take the case of Appalachians here, Appalachians in North America, now, these also, at one point of time, this was an active plate boundary when North American plate was colliding with the Eurasian landmass. It was an active plate boundary. But later on, the convection current happened somewhere else, creating a mid-oceanic ridge. And now this is a passive plate boundary, right? When you talk about the mountains that you observe in the region of the Eastern Ghats, not mountains, they are hills basically, they are much smaller. They cannot be classified as a mountain at all. In under no circumstance the region of the Eastern Ghats can be classified as a mountain. So these have been in existence when the land got created in this area. And when they underwent collision with each other, the small lands that got created, the region of Chota Nagpur, the region around Bastar Plateau, the region around Karnataka Highlands, when they got created, there the convergence between them and also between those regions and the oceans nearby, that has created these particular mountains in many of the areas. Okay. Some older plates have disappeared or merged, leaving behind many features. Yes, that is true. They have not disappeared, but basically they have merged. For example, as you had pointed out, the Ural ranges. The Ural ranges are also fold mountain. At one point of time, it is expected that these two would have been active plates, but now they are not. Right. So you have such kind of plate features. So this was at one point of time an active plate boundary. It is not. This was an active plate boundary at one point of time. Now it is not. So tomorrow, let's suppose after few years, there is a convection current which develops in this region, and the convection current in this region disappears, then Himalayas won't be at a plate boundary anymore. right? What caused the smaller islands above North America? Okay, this many of them have volcanic origin, but then the dissection of it happened significantly during the last ice age, where the glacial erosion paved way for depressions in these areas which have been occupied by shallow water bodies. So that is something that you find even in this region of northern portion of Europe, even in the southern portion of New Zealand, etc. So that is one of the reasons for that. But just like the case of the Deccan Plateau, where the Deccan Trap also was due to a large scale basaltic lava eruption, here also Canadian Shield got created due to such large scale lava eruption long time back. So it is all of them have got a volcanic origin, but there you don't have a plate margin. Okay. Will the mountains remain? See, there is always a kind of interplay between the internal forces which are trying to uplift the mountain and external forces which are trying to erode these particular features. As soon as the internal forces come to an end, then you will have only the external forces which are trying to erode. So it leads to the general degradation of the mountains. Just like the Aravallis, at one point of time, it is estimated Aravallis were so tall that the peaks were covered with ice, and you had glaciers which would originate from the Aravallis. They were so very mighty. But today, look at the Aravallis, what the condition is today. So they get eroded over a period of time, they get eroded. Can you please make direction in the same page where you draw BM? Okay. But what is your doubt, Priya? Please ask the doubt. What is the doubt? That can the parallel movement of the plates happen, if that is the doubt, or will it be perpendicular to the divergent plate? That is the doubt. Or where these parallel movement of plates will happen? That is the doubt. What is the exact doubt that you are having? Your first question was that my question is that does the plate itself travel in other direction, like A part in northern and B part in southern direction? What if B and B dash goes in opposite direction? Yes, that can happen. That can happen here. This particular movement that you see, this is happening in opposite direction. The kind of parallel movement of plates that you observe. So here, even in this portion, here observe the parallel movement of the plates there, that is happening in opposite direction. That is the case. It can always happen. It depends on whether the other plates are impacted by that or not. If that was your question, was that your question, or was the question something else? So the plates need not move in the same direction. The plates, when we say parallel movement, they can always move in opposite direction. That can always happen. Why not? Was that the doubt, or is the doubt something else? A water body sea in North America plate. How it's happened? Ganesh, you are talking about the this region. Is it the area that you are talking about, the Hudson Bay? Is that what you are talking about? So basically, that has been created due to, this is what is the Hudson Bay. This has been created due to glacial erosion. During the last ice age, all these areas were covered by ice, and that glacial erosion eroded the land quite significantly. And when everything melted, seawater entered into those depressed areas, and that is how you had these water bodies getting created. Okay, and after crack, what if B and B dash goes in opposite direction after crack, because of, like, A and B are 2 points, and now B and B dash, B having B and B dash, can B and B dash travel opposite to each other in direction? No, no, they can't. They can't. I understood the question finally, if I think so, but I'm not sure of myself. Maybe I did not understand. So your question that you are trying to ask is that from this point of divergence, Can it happen that B moves in this direction and after the formation of crack, B dash starts moving in that direction? No, it will not happen, because here you have the divergence of plates which is happening. It is the divergence. So both of them will be pushed in this direction. Okay. So it won't happen. So both of them in this case are pushed in the same direction. Let me draw the image again. Let me draw the diagram again. Is it the case that others are able to understand the question? I am not able to understand. Is there any reason due to which northern hemisphere has large landmass than the southern hemisphere? No particular geographical reason in such. It has a historical connotation of it. So let me find an empty slide. Understand it once again. Understand this. Divergence of plates. If you have a particular plate like this, or let's assume you have two plates. Let's assume you have here the presence of two plates. This is A, this is B. There is divergence between these two plates because there is a convection current in between them. If there is a convection current between them, then A and B will always be moving away from each other. Okay. Now it can happen that the rate of divergence in the portion here, that is, let me mark this portion as 0.1. Let me mark this portion as 0.2. It can happen that the rate of divergence at 1 is different than the rate of divergence at 2. Okay, so that means B, the plate B in itself, that is getting pushed apart at different rate in north and south direction. If let's suppose we mark this as the north direction of B, if we mark it as south direction of B, so B in itself is moving in the same direction, that is the eastward direction. That is where B is moving. But then both ends of the B plate, they are moving at a different rate. Okay, B is moving eastward due to divergence. But northern part of B is moving at a different speed as compared to southern part. I feel I am trying to dictate things. Southern part. That means B will experience tension can lead to breakage, formation of transform boundary. Can lead to the formation of a transform boundary. Let's suppose there's a transform boundary which gets created here. So if we consider this particular, okay, let me name this as the B. When gets divided, the B plate gets divided into C and D, right? So both C and D are going to move in the same direction but at different rate. So this is going to be your transform plate boundary because they are moving parallel to each other. Now here, if your question is cannot D move towards A, it cannot be the case because there is a convection current which is pushing the entirety of the plate eastward. Is that understood, or is the question still something different? Please let me know. Shiva, can this difference in rate of movement between two parts of a single plate happen during convergence? No. No. Ganesh, my dear friend, you were always clear with this. I'm asking about the people who had asked this question. So is that clear about the transform boundary, or is there any doubt which still persists? Please let me know. Now, meanwhile, we handle the PYQs which have been asked from this particular area. So, which of the following phenomena might have influenced the evolution of organisms? How is it that the evolution came into, or of the evolution of the organisms? How have they been impacted, if at all? So you have continental drift, glacial cycles. Which of them have influenced the evolution of organisms? Okay, it is clear. The doubt is clear. Good. Till now, I have not been able to understand, by the way, what the question was. So, by the way, the live call feature is allowed. So, if you want to, if you are unable to express your doubt, you can always avail the live call feature. Many of the time, I feel that you are unable to type it out what you are trying to ask exactly. By the way, that is a characteristic which will be very much required while you are writing the mains exam. Good. Majority of you have given the correct answer. So the correct answer in this case is C. Both 1 and 2. Both of them are going to impact the evolution of organisms. As the climatic conditions, the natural conditions change, the organisms also have to adapt accordingly. So that is why both glacial cycles as well as continental drift are going to bring about that change. Which of the following pairs is or are correctly matched? Here you have the theory or the law, and the other side you have the associated scientists. So which of them are correctly matched? Sudeep, I think it should be available. Good. So here, continental drift was given by Alfred Wagner. Expansion of universe was given by Edwin Hubble. So both of them are incorrectly matched. Photoelectric effect was provided by Albert Einstein. So this is correct. So the correct answer is B. That is 3 only. Then, in the structure of planet Earth, below the mantle, the core is mainly made up of which of the following? Which of the following elements they are abundant in the region of the core? Good. It is going to be iron. Iron and nickel, they are the ones which are abundant. Okay. We have some more questions which are there. So if you want, we can take up those questions. So Right. Variations in the length of daytime and nighttime from vary between season to season because of, right, so variations in length of daytime and nighttime from season to season are due to Earth's rotation on its axis, the Earth's revolution around the sun in an elliptical manner, latitudinal position of the place, revolution of the Earth on a tilted axis. The most appropriate answer you have to find out. Good, very good. It is because of revolution of the Earth on a tilted axis. That is why different regions get different exposure to sunlight. Okay, and different amount of daytime and nighttime. Now, the subjective type of questions which have been asked from the area: explain the formation of thousands of islands in Indonesian and Philippine archipelago. Now, here, basically, how or why is that created? Why do you have these thousands of islands created in Indonesian and Philippine archipelago? Because of ocean convergence. Oceanic convergence. Okay. So here in this answer, how do you create the answer? In the introduction, you have to talk about that. The basic introduction you have to provide that the Indonesian and the Philippine archipelago, they are composed of thousands, hundreds and thousands of islands, and this formation can be explained by the process of plate tectonics. So it is in this area where then comes the body. So in the body you start explaining that is many of these islands being volcanic in nature have been created because of the convergence of oceanic plates with each other. Then, with the help of the schematic diagram, you have to talk about that what happens when you have the oceanic plates converging with respect to each other, what kind of landforms are created. All that you have to explain and elaborate upon that. When is it that the island formation takes place? Okay. Can we send the answer of this question for target IS? Absolutely yes. We have discussed 2 to 3 PYQs. Write it out and send it to target IS. Why are the world's fold mountain systems located across the margin of the continents? Bring out the association between the global distribution of fold mountains and earthquakes and volcanoes. This is a question that you will be able to solve much better once you cover the portion of earthquakes and volcanoes. Mantle plume is again something you have not covered. This question again you can attempt. Discuss the geophysical characteristics of the circum-Pacific zone. So in this, while you are writing the answer, introduction, you have to talk about what do you mean by the circum-Pacific zone. Okay, so that is what you have to explain in the portion of the introduction. So basically, the circum-Pacific zone or the region around the Pacific experiences significant geological activities such as earthquakes and volcanoes with a greater frequency. That will be your portion of introduction. Then when you start with the body portion of it, in the body you have to talk about that how these particular events are initiated due to continental oceanic and oceanic convergences. You can give the examples of the plates concerned as well with the help of schematic diagram, rough map around the Pacific. You can virtually talk about the why earthquakes happen, why volcanoes happen, what are the properties. You have the existence of the trenches as well. You can give the example of these trenches as well, and that will be your answer complete. Okay, I hope that is understood. Now, after this, we come over to the portion of earthquakes, volcanoes, faults, and faults. Before that, do you need a break or do we continue till 8? Okay, we'll take a break. So we take a break and leaderboard you want. Okay, this is the leaderboard. Many of you have given all the answers correctly. So here Now we'll take a break. We'll take a break till 7:05 and then we will continue. 5 p.m. and we continue after that. Okay? A confirmation about the audio, please. If the audio is clear and available, kindly confirm. Thank you. So now we come to the next module where we deal with the portion of earthquakes, volcanoes, and also how is it that basically the movement across the planet that ends up creating the existence of various different types of folds, classification of folds, faults, etc. That is what we are going to take a look into. So first of all, when we talk about this particular area, relevance for your examination. So in your prelims, even this year, you had a direct question asked from this area, and question was framed exactly what we discussed in the class and as per the requirement of the PPT itself. So here, basics of earthquakes, that is intensity, magnitude, etc. Magnitude, etc. Then seismic waves and properties. Then after that, you also will find questions coming from the region of basics of volcanic eruptions, volcanoes, classification based on magma, types of intrusive landforms, intrusive volcanic landforms. Then in the mains examination, also this area has been found to be very relevant. So in the mains examination, you do get questions about shadow zone of the seismic waves, then basically global distribution of earthquakes, then mantle plume and hotspots. Then after that, global distribution of volcanoes. So these are the areas from where questions have been asked and they are repeated also multiple times. So these are the portions that we will concentrate upon as we move ahead. So first of all, we shall try to gain an idea about what do we understand by an earthquake. Then the various nuances, intricacies of an earthquake. Here sometimes you also get questions about human induced earthquakes. Human induced earthquakes. Okay. So that is something that we are going to concentrate upon. So we are going to start our discussion with earthquakes, then we will reach the portion of volcanoes. Now, we have basically familiarized ourselves with the basics of what do we understand by an earthquake, what do we understand by a volcano. We have already familiarized ourselves with that particular concept, right? So when we say earthquake, now what is the meaning of it? Earthquake has occurred means the land has started shaking up or there has been a shaking of the land surface. That is an earthquake. Now, why will the land surface ever start shaking up? There would be tremendous amount of energy which would be released, and in that process of that release of energy, you would have the shaking of the earth surface also. But why is that energy released, and where is that energy released? So we have seen that as various different layers, the crustal region, the rocky portions, as they try to move with respect to each other, as and when they try to have a movement with respect to each other, there is always going to be a kind of resistance that they offer. Resistance that they offer for each other. Let's suppose you can do one thing, you can put the two fists of your hands and you can try to move them with respect to each other with some force. You will observe that there's a kind of a resistance that the various different fingers they offer to each other. So as you try to push them, eventually you will have a sudden movement. So whenever that sudden movement happens, wherever underground that happens, that leads to a tremendous release of energy. And that is what we experience as the shaking of the earth's surface, leading to or causing a kind of an earthquake. So that is what we have as an earthquake. So when we say what is an earthquake, so earthquakes are caused due to the sudden release of enormous amount of energy accumulated within the earth. As the particles, the materials, they try to move against each other, that is also one of the reasons for an earthquake. Sometimes even during volcanic eruptions, you will find that the molten material, it tries to come out, but it faces some or the other obstruction in between. So that will also end up shaking the earth's surface. So that is why before a volcanic eruption also sometimes you experience earthquakes. Sometimes it can also happen that during the volcanic eruption gases are trying to come out, but then they also face a kind of an obstruction, so that also shakes the earth's surface. Any kind of force, event, energy which will lead to the shaking or the disturbance of the earth's surface, naturally or artificially, is referred to as an earthquake. Now the point in the interior where that release of energy happens, that point is referred to as the focus of an earthquake. Okay, so when we say focus, focus is basically the region or the point in the interior where the energy is released. Now, the depth of focus can vary, and it varies in different cases. You would hear about the terms also, you would hear about the news also, that this earthquake has occurred with its focus 60 kilometers below the surface, 100 kilometers below the surface. So, such kind of events you get the news about, right? So, based upon where the focus has been or where is the focus, earthquakes are also divided into different types. So classification both based upon focus. Classification based upon focus. So you have shallow focus earthquakes, focus earthquakes. Now, when we say shallow focus earthquake, in these areas or in these cases, the focus lies up till a depth of 100 kilometers from the surface. So, up to a depth of 100 kilometers from the surface, obviously. Then you have intermediate focus earthquake. Earthquake. Now, this intermediate focus will have the earthquake occurring, the focus of it lying between 100 to 300 kilometers, sometimes even 400 kilometers. So 100 kilometer to 300 kilometer. And then you have the deep focus earthquake, which is rare. Deep focus earthquake, which is not very common, which is substantially rare. Now that is basically 300 kilometers to 700 kilometers depth. Now, beyond the depth of 700 kilometers, you won't generally observe the occurrence of an earthquake, because beyond the depth of 700 kilometers, the materials, they won't move, or they won't have resistance and rub against each other. The compression and the amount of pressure is so high that beyond that depth, materials will rather deform themselves than move against each other. So if there is a lot of pressure exerted, the materials simply will deform themselves. So that is why no earthquake occurs beyond that depth. Now, here, when we talk about which earthquake is more dangerous, shallow focus, intermediate focus, or deep focus, generally it depends upon the amount of energy released. But whenever you have the energy which is released closer to the surface, that will always end up getting significantly dangerous. It will have a lot of impact created. So here, now the focus can be 60 kilometers deep beneath a region, it can be 100 kilometers deep beneath a region. Now, for common reference, how is it that you will refer it for the common individual and for scientific purposes as well? So for that, we demarcate an area immediately above and perpendicular to the focus, that is the epicenter. So epicenter is present directly above the region of the focus, perpendicular above the region of the focus, and it marks the origin point of the earthquake. It is from here that the energy spreads outwards. Right. So epicenter of an earthquake is the region immediately above the focus, is considered to be the region where you have the origin or the genesis of the earthquake. Bhuj earthquake in Gujarat had its epicenter at Bhuj. Right. Similarly, Kathmandu earthquake, the Nepal earthquake 2015 had its epicenter at Kathmandu. So that is how you have the epicenter for your common reference points. Now, when we talk about an earthquake, now, earthquake has got significant amount of damage causing potential. It can create a lot of havoc, lot of damage, lot of destruction. We have seen recently what happened in Libya, what happened in Morocco. We have seen that, isn't it? Before that, what happened in Turkey. In India also, we have faced devastating amount of earthquake. Now, almost a century and half ago, or century back, that is in the early 1900s, we did not have any mechanism by which we could measure the amount of energy released during an earthquake. So earthquake at that point of time would be classified based upon the damage and the destruction cost. That means, based upon the fact that whether an earthquake has occurred, which we have all felt, but there's no building which has fallen, so it would be put in the lighter category. And let's suppose an earthquake has occurred where all the buildings have basically fallen, so the heaviest category. So that used to be the classifying criteria earlier about the various different earthquakes. This was referred to as the intensity of the earthquake. So when you hear the term intensity of the earthquake, it tells you about the damage causing potential of a particular earthquake. Okay. So here, the intensity of an earthquake refers to the damage causing potential of an earthquake. Now, the damage caused by an earthquake, that is never going to be absolute. It is going to vary on a lot of factors. For example, if I give you the example in this case, let's suppose we consider three different places. Now, in all the cases, let us assume that the earthquake has occurred of same amount of energy has been released. So let's talk about A, B, and C. Same amount of energy is released. But in one case, it has occurred at a depth of 60 kilometers. The focus is at a depth of 60 kilometers. In other case, the focus is at a depth of 170 kilometers or 200 kilometers, let's assume. In other case, let's assume it has occurred at a depth of 500 kilometers. If all of them, they have released the same amount of energy, where the damage will be maximum, A, B, or C? What do you think? Where do you think the damage will be more in this case? A, right? I don't think there is much of a thought required in this. A will experience greater amount of damage. Why? Because A is where the focus and the energy is released closer to the ground surface. Now, let us consider another aspect here. Now, let us assume that all these three places, they have experienced the earthquake of the same intensity. Now, in the first place, you have buildings which are earthquake resistant. All the buildings are earthquake resistance. In B, you have buildings which have haphazardly been built. Okay. And C consists of huts and hutments. So in this, least amount of damage will be caused where? A, because A is where you have the earthquake resistant buildings, in the sense that they can tolerate significant amount of shaking caused due to the earthquake. So here again, the damage causing potential varies. Again, for example, if we consider that the region of A, the region of B, and the region of C, let's assume that they are made up of different materials. A, hard rock. B is considered to be made of soft soil sediments in a river floodplain. When an earthquake occurs, obviously the sedimentary region or the soil region, they will follow a kind of a wave pattern. The ground will break up, the damage will be more. So, because the damage caused by any earthquake is dependent on the nature of the surface, the depth at which the focus lies, what are the various different intricacies of settlement, the strength of the buildings, the early warning system, everything, the population density, all of that ends up determining the damage causing potential. So, that cannot always be a perfect criteria for classifying an earthquake. So for an earthquake, you need to also measure the amount of energy which is released. Every time an earthquake occurs, what is the total amount of energy released? So that energy which is released, that is basically measured with the help of a seismograph. So a seismograph, basically, it resembles your something like an ECG machine. So when we talk about a seismograph, so there you will observe that a roll of paper is basically furnished and it comes out of a machine. On that machine, you have the markings. And here you will observe that a pencil basically keeps on moving across this particular machine. So here you will observe that under normal circumstances, it will revolve like this. But then suddenly when an earthquake occurs, the pencil will indicate a kind of a variation. So that basically indicates to you that yes, energy has been released. So this marking or deviation from the normal that you see in the case of a seismograph, that ends up depicting the amount of energy released. And when you measure this energy, amplitude of the energy released, that gives us the idea about magnitude of an earthquake. So when you talk about the magnitude of the earthquake, it basically talks about measures, or rather indicates the amount of energy released by measuring the amplitude of energy. So that is what you regard as the magnitude of an earthquake. So that is the basic difference between the intensity and magnitude. Intensity, again, I will reiterate, basically signifies or gives you an idea about the damage causing potential, how much amount or to what extent the region has experienced any amount of damage, if at all. So what is that damage causing potential? So that idea you will get with the help of intensity. So intensity is measured with the help of a scaling. There also it is done. For example, the grade 1 earthquake, where the earth has basically shaken up but you have not felt it. Every day you have hundreds of earthquakes which occur across the planet. Not many of them are felt by us. Very few of them are felt by us when they have a slightly greater amount of energy released, right? But all of them are measured on seismographs and observing stations that you have present across the entirety of the globe. So grade 1 earthquake, maybe you have not, nobody has felt it. Grade 2 earthquake, we have felt it but very minutely. So grade 3, there has been a substantial amount of discomfort because of the shaking which is created. Grade 4, where you had to evacuate the house because of the conditions of the shaking of the surface. Grade 5, all the buildings started shaking. So like that, you have the classification. This is what is also referred to as the Mercalli scale. And Mercalli scale over a period of time has been modified to include further more parameters of damage. So that is what is used for measuring the intensity. So here, modified Mercalli scale is used to indicate or to classify the earthquake based upon the damage caused. Okay. And when we talk about magnitude, that basically is measured with the amount of amplitude of energy that is released. That is measured with the help of a Richter scale. Measured with the help of a Richter scale. Okay. So that is basically used in this case, that is basically observed when we talk about an earthquake. So this is the differentiation Mercalli scale. It is used to represent the intensity of the earthquake. The modified Mercalli scale's range varies between 1 to 12. Richter scale represents the magnitude of the earthquake. So when you hear that the earthquake of magnitude 5.7, 6, etc. has occurred, that is the representation on the Richter scale. It is logarithmic in nature. This Richter scale is basically logarithmic in nature. And what does that mean? Means magnitude, earthquake of magnitude 7 magnitude 7 is 10 times more powerful than earthquake of magnitude 6. Okay, earthquake of magnitude 8, basically when we say more powerful, we basically mean it releases 10 times more energy. So that means it releases 10 times more energy. Releases 10 times more energy. Okay. So whenever an earthquake occurs, whenever an earthquake occurs, immediately the energy which is released, that is captured by the various seismographs that we have across the entirety of the planet. And based upon the damage causing potential, also you have the Mercalli scale classification which is done. But generally, because the rate of destruction caused in different parts of the planet is so very dependent on the local characteristic of construction materials, the land surfaces, etc. That is why intensity is not a frequently used factor, but magnitude is. So that is why immediately when an earthquake occurs and it causes damage, very immediately you will observe that all the various different meteorological stations, they will release the information that, okay, earthquake of XYZ magnitude has occurred with its epicenter and focus in this particular region. So that is how it is issued. That is how one gets intimidated or gets informed about it. So amount of energy released by an earthquake called its magnitude can be measured by the amplitude of the seismic waves produced. By using these two scales, the intensity and magnitude can be estimated before. By using the two scales, the intensity and magnitude can be estimated before the damage. But how will you estimate that unless and until you don't have an earthquake which has occurred? Only after an earthquake has occurred will you be able to measure the amount of damage which is caused. Only after the earthquake has occurred will you be able to measure the amount of energy released. So how will you be able to measure before the earthquake has occurred? So Parshuram, that cannot be done. Only after the earthquake has occurred, that is when we get all these kind of information. Now, when the earthquake occurs, it releases a lot of energy, and though that energy travels in the form of waves, and that is what we refer to as seismic waves or seismic waves. So basically, these seismic waves, they can come into existence whenever you have the occurrence of an earthquake. So when an earthquake occurs, it releases waves of energy which are known as seismic waves in general. Okay. Now, here, earthquake occurs in the interior of the planet, right? At a particular depth, that is where the earthquake occurs. Now, understand this part. So, let's suppose this is the surface. Here, the earthquake has occurred. This is the region where you have the focus. Now, once the earthquake has occurred, it will release energy. Now, the energy released, will that energy be unidirectional or will that energy be multidirectional? What do you think? Will that energy be released only in one direction or will that energy be multidirectional? Very good. Energy is always multidirectional, right? Any kind of energy that is produced is always multidirectional. You provide direction to it by providing various different artificial means, but be it sound, be it light, energy is always multidirectional. So energy will be released in all different directions. Okay, but then some energy will immediately hit the surface. Now this is your focus, so this will be your epicenter. Right. Now, if you can imagine about it across the representation of the planet, so you can think that here you have the earthquake which has occurred, and that earthquake has released energy which travels in all various different directions. It does travel in all different directions, but it is traveling within the body of the earth, right? All that energy wave is traveling through the body of the earth itself, right? Once it hits the surface, it will disturb the surface. Let's suppose this is the surface, let's suppose, and the energy has hit the surface. But if the surface is disturbed, now that will lead to the disturbance of the other portions of the surface as well, isn't it? Because here the body wave, the portion of the energy coming from the interior, they have hit it here. Now the surface at the epicenter is disturbed. That will disturb the rest of the surface. So you will have the energy waves upon hitting the portion of the epicenter, you will have newer energy waves which will be transmitted across the region of the surface as well. So accordingly, seismic waves are also classified into two types, that is body waves and the surface waves. Body waves basically travel through the interior of the planet. Travel through the interior of the planet. Whereas when we talk about the surface waves, they end up basically travel through the surface, generally move outwards from the region of the epicenter. Just like how the ripples, they end up traveling in water, in a very similar fashion, in a very similar manner, you will find that basically these surface waves, they travel outwards from the region of epicenter. It is at the region of the epicenter where the body waves will disturb the surface, and then that will lead to the generation of new kind of surface waves which get created. So in a way, you can also argue that surface waves, they come into existence after the body waves hit the epicenter. Okay, so they come into existence after the body waves hit or disturb the epicenter. Okay, now after this, basically, let us take a look at the different kinds of waves. So this is to indicate and depict to you that how do these waves, they travel outwards. So from the region, the waves, so just like when you throw a stone into water, you would observe that you are basically disturbing one point in water, right? When you are throwing stone in water, all that you are doing is disturbing one particular point in water, but then the entire region of the water is disturbed. So think about it, that the body waves will disturb the region of the epicenter, but that in turn will generate ripples which will impact the entire region. So farther away from the epicenter that you go, the amount of damage, the amount of energy that you receive, that keeps on reducing. Okay, now let us take a look at these seismic waves in a slightly greater detail, and we start with the portion of the body waves. Okay, now body waves themselves, they are classified into two types. Even though there are multiple different types or categories of the body waves, you have the basic types, that is the P and S wave, that is something that we are going to study. But you also have PG, SG, P star S, S star G, and so on. You have many different types of body waves, but not relevant for your prelims, for your general studies. So here we are going to study the two types, that is the P waves and the S waves. When an earthquake occurs, both of them are released. So energy is released in the form of P and S waves simultaneously. So whenever you have an earthquake which occurs, whenever an earthquake occurs, both P and S waves are released from focus simultaneously. Okay, at the same time they are released, but then both of them will impact, or they will travel in a different manner. Okay, it is after all that energy which is released that travels in the form of P wave or an S wave. But what are they? Let us try to understand that. So when we talk about each one of them, so before that, here, when we talk about the P waves, so they are also referred to as the primary waves. Primary waves. Okay. Now here, how do they travel? And what is the motion of the particle involved? So let's suppose here you have the focus and you have the various different particles which are associated. Now, generally, the P waves, they travel very similar to that of a sound wave. And how does the sound wave travel? Compression, expansion, compression, expansion, compression, expansion. That is how the sound wave is basically uh, traveling. That is how the sound wave travels. So here, let's suppose this is the portion of your focus. It is here that the energy is released. Now, the wave will move in this direction, direction of wave motion. Now, what about the particles here? Now, in this case, just like it travels in the case of the sound wave, the particles will start vibrating to and fro. Now, first particle starts vibrating. It will disturb the second particle. That will also instigate a vibration. That will disturb the third particle. And that will disturb the fourth particle. So, like that, basically, the particle movement also, in a way, that is responsible for the propagation of the wave, isn't it? So the particle motion, you will find that it basically ends up moving continuously. So the particles, they end up disturbing with each other, and that is how it propagates further ahead. So here you will observe that the particles in this case, or the wave which is getting translated in the form of getting compressed, then expanded, again getting compressed, again expanded. After some time, the regions which were compressed would be expanded, the regions of expansion would be compressed, and like that, the wave would travel forward. Okay, by compression and expansion. So in this case, what you observe is that the direction of wave motion and the direction of the particle motion is the same. So the wave is also moving in the same, in this direction, suppose, and the particle is also moving in the same direction. So that is why the wave is able to transmit itself much faster with a speed of with a speed of significantly 4.5 to 6. So that is why here direction of wave motion, direction of wave motion is the same as the direction of particle movement. Okay, direction of wave motion is the same as the direction of particle movement in general. Hence, this is able to travel very faster. Hence, the P waves travel very quickly. Okay, they are able to travel, they are able to get transmitted very quickly. Now, because the wave motion, the particle motion, each of the particles, they are getting disturbed in the same manner. Now here, what about the case of liquid and gases? So let's suppose you have a liquid medium. So liquid medium particles are further away from each other. Let's suppose here the energy is getting transmitted. So the first particle will undergo a to and fro motion. That will disturb the space of the second particle also. So the second particle also will get disturbed. The third particle also will get disturbed. The fourth particle will also get disturbed, isn't it? So because again of the same reason that the particle motion and the wave motion are in the same direction, hence p waves are able to travel through solids, liquids, and gases. They are able to travel through all of them, right? Because they are able to travel through solid, liquid, gases. Why? Because again, even if the particles are far away, if this one gets disturbed, it will always end up disturbing the second one. That will always end up disturbing the third one. Having said that, if the density of the substance is higher, if the density of the material is higher, the speed of movement of the waves is also going to be higher. Always keep that in mind. Any of these waves, any of the seismic waves, they will travel much faster if the density of the material is higher. So speed of the body waves is directly proportional to density of the material. Okay, that is what you will observe in this case. So greater density always is associated with a higher amount of speed. Okay, so density of material, here we are referring to the crust, the mantle, any of those. So even in the crust, you have various different materials. You have various different, sometimes some empty spaces also are there. So there also, they are able to travel depending upon the density. In the region of core also they travel. The P waves can travel through the region of the outer core as well. Okay. Now, when we talk about the S waves or the secondary waves, now these end up traveling very similar to how the sound travels, or rather how light travels. So light travels in the form of a sinusoidal wave. Something very similar happens here also. So let's suppose this is the origin point or the focus, and here you have the various different particles. Okay, let's assume this is the focus. Now the direction of wave motion is in this way. Of wave motion. So here, how is it that the particles are disturbed? So the particles, they move perpendicular to each other. In the sense, this particle will be disturbed because of the energy released. The particle will disturb like this. Now, imagine in the solid, all the particles are joined with each other. If the first particle moves like this, the second particle will also follow suit. The third particle will also get disturbed like that. And all these particles, in a way, they get disturbed. But how does the wave propagate? So the wave propagates in a manner somewhat like this. Okay. The wave basically ends up propagating like this. So in this case, the direction of wave motion is perpendicular to the direction of the particle motion. Direction of wave motion is perpendicular to the direction of particle movement. So obviously, if the direction of wave motion is perpendicular to the direction of particle movement, the wave won't be able to propagate itself with that quick manner. It will take some time for the wave to get propagated, isn't it? It will take a lot of time. So hence, S waves in comparison to the P waves, they are slower. So that is why it takes some time for the wave to get propagated or transmitted. Hence, it is slower. S waves are slower. Okay. Now, furthermore, if we talk about the liquid medium in this situation, let's suppose we talk about the liquid medium. Now, in the liquid medium, let's suppose the first particle is disturbed like this. Now, will it be able to influence the second particle? Maybe a little bit. Maybe the second particle gets disturbed ever so slightly. But by the time that you reach the third particle, the disturbance further reduces. And the fourth particle might not get disturbed at all. Why? Because the particles in liquid and gases, they are so far away from each other that a movement which is perpendicular, that won't be able to disturb the other particles. Hence, because of this, S waves, they cannot travel through liquids and gases, whereas the P waves, they can travel through all the kinds of materials. Okay, so that is the basic about the seismic waves, the P and the S waves. Here S waves will travel by basically a kind of a sine curve like this. P wave will travel by compression, expansion, just like in the case of sound waves. So when we talk about the difference between them, P waves and S waves, P waves basically are the first waves to hit the Earth's surface. Why? Because they are faster. They are comparatively faster than S waves. Why are they faster? Because the direction of wave motion is same as the direction of the particle movement, and they arrive generally after P waves. So these waves travel at the speed of 4.5 to 13 kilometer per second, and these waves almost hit 1.7 times to 8 times slower than basically the P waves. Okay, now P waves travel in a linear direction through compression, rarefaction, etc. They can travel through solid, liquid, and gases. Where they travel, S waves travel in a transversal direction, very similar to that of a light wave, and they can travel only through the solids. At a time when an earthquake occurs, both of them are released simultaneously. It is the P waves, because they are traveling faster, they will be able to hit the ground surface earliest. This information is used for designing the earthquake early warning systems, because generally P waves, they end up hitting the surface almost a minute earlier than the S waves, or sometimes even 2 minutes, 3 minutes earlier as compared to the S wave, the other part of the body waves, and impact on the epicenter. So the first portion of the P waves, they shoot up and they hit the surface. Japan is so very earthquake prone, and Japan also experiences very high magnitude earthquakes with quite a significant amount of frequency. Now, Japan as a country suffered a lot of disaster because Japan also operates high speed rail, bullet train, and that bullet train, basically during an earthquake, one time it happened that the bullet train was thrown off its rail and it simply flung to a far off distance, leading to massive casualties. What Japan then installed was the P wave detection systems, where immediately upon detection of the P waves, all the sirens across the region, they start blaring off. Now you might think that 1 minute or 30 seconds or 90 seconds, that is not enough. But oftentimes that much time is more than sufficient to give you an idea that where to hide, what to do to save yourself from that particular disaster. And in the case of the bullet train network, as soon as that alarm hits, all the emergency brakes are applied, and within 30 seconds, all the trains come to a halt wherever they are. And with that, they are able to avert any situations of emergency whatsoever. So that is what I was telling you, that if you are aware of geography and the geographical realities, disaster management is something which is a natural follow up to it. For that, all you need to understand how that disaster happens. Earthquake is a major disaster. Okay. So that is where we'll do one thing. We'll restrict the session here today. I want you to take up the revision of the portions that we have covered in the weekend. And in the next weekend that we meet again, we will continue our discussion from that area. Okay. So I hope that the session has been helpful to you guys. And in how all home will be earthquake proof. Not all the homes will be earthquake proof. The buildings which are erected, those buildings basically, they have the earthquake proof construction, where you have the installation which goes underground as well. So the shaking which happens, the lower portions are allowed to shake, and the upper portion of the building, that simply rolls with the help of certain larger ball bearings. It rolls horizontally so that the lower portion withstands all the shock, but the upper portion stands still. Which are more powerful, the P or the S waves? It is basically the surface waves. That is the one which causes all the destruction. P and S waves, they will just impact the epicenter. Is this module will also help in disaster management? Always. You know, this year in mains, you had a prelims, you had a direct question from this particular slide itself. From these particular areas, we'll take up that question in the next weekend. You had a direct question appearing from this. Okay, right? So that is where we'll restrict the session. Vishal, map work, we'll try to have it for the next weekend. And Satish, you can find the portions of the interior of the planet Earth, continental drift, plate tectonics, that is origin of continents and oceans. Those are the areas that you can cover. Okay. So that is where we'll end the session here today, guys. Any doubt that persists, that has somehow or for some reason remained unanswered, kindly do get in touch. You can write to us, mail to us, and we'll get back to you immediately. Okay. So I hope that weekend has been tolerable, if nothing, and meaningful and beneficial for you. We meet again next weekend, where we further finish the portion of geomorphology and we enter into the portion of climatology next weekend. So that will be all from my side. Do take care of yourself, relax. Thank you. Goodbye and have a good night.